Okay, the next thing we're going to do is we're going to have a look at, where is it? This equation of a tangent equation to a perpendicular line. So let's say we've got our function of, I don't know, menu, let's draw negative x minus 2 all squared, all squared plus, plus 3. Okay, now we're going to draw a tangent at x equals 1, 2, 3. So we're going to draw a tangent at x equals 3. So the tangent here is x equals 3. So what we want, we're going to now take this, we're going to take this, I'm going to copy it, we're going to draw a tangent to that, tangent at x equals 3 for that thing there. Okay, it's giving me an error, but I'm just saying that's what we've got. So I am going to define this, f of x equals that, and it's given me that. So now I want to, now to find the tangent, remember I want to write it in terms of y equals m times x plus c. That's what I want to write it as. So where where m is the gradient, x and y are our points, and c. So if x is equal to 3, now we've got to find the value of f of 3. So it's 2. So we're going to find a tangent at 3 and 2. So to do that, we've got to find the gradient at x equals 3. So what we're going to do, we're going to say menu, calculus, derivative at a point, variable is x, the value is at x equals 3. And we're going to say for f of x, so telling us that our gradient there is negative 2. So that's our value for m. So then here, we've now got y equals mx plus c. Now we know that y equals 2, because that's what we found here. So at x equals 3, y equals 2, and we're going to solve for c. So I'm going to put this in there. So I'm going to say solve, comma c. Now it's telling me, whoops, that's no good. Oh no, let's get our gradient m. M we know here is negative 2, so we've got to put that in there as well. Negative 2. And then we have c is 8. So therefore, in y equals mx plus c, we'll have y equals negative 2x plus 8. And that's what we'll graph. 2x plus 8, let's just check that. 2x plus 8. Negative 2x plus 8. And there, we've got our tangent right there. So we're at negative 2x plus 8. So just to go through that again, we wanted to find at the tangent at x equals 3 for this function. So we define the function. We want to write our tangent in terms of y equals mx plus c. At x equals 3, f of 3 equals 2. We then find the derivative of f of x at 3. That equals negative 2. We substitute that into y equals mx plus c. So this line was incorrect because I didn't put my value of m, which is negative 2. So once we've got that, we solve for c, and we end up with our value, and then we put in our equation to the tangent. Now, we want an equation to a normal. We're the same deal. We're going to have an equation to a normal here, or at 90 degrees. So we know that that happens, so if m equals negative 2, then m of the normal equals 1 over 2, because it's a negative reciprocal of this. So what we'll do the same thing. Now it's at the same point, so our x values and our y value will be the same. So what we do is we say solve 8 equals, 2 equals negative, 1 over 2, because it's our new gradient, times 3 plus c for c. And it tells us that c is a half. So based on that, we'll say that y equals 1 over 2 x plus 1 over 2. That's what we've got there. So that's our new gradient, that's our new y-intercept. So let's check that. Tab 1 over 2x plus 1 over 2. and there you have it, crossing right there at right angles. So they're the steps to take. So with this, what we do, we want to find the next intercept. Sorry, we want to find a tangent at x value. We define our function. We write down f of that x value. It gives us a y value. Find a derivative at that point. That gives the value for m. Substitute that into y equals mx plus c. So we've got y equals mx plus c, because this is choosing our point, and plus c, we're solving for c. Give us a value for c. We put that back into y equals mx plus c. And if it asks us to find the normal negative reciprocal of our gradient, so we've got -2, so it's got to be a half. The -1 over that is a half. We substitute that back into y equals mx plus c. We solve for c, and we get our equation. And just to be sure, we graph it as well.